Okay, and started. So thanks everyone joining us for our Window Code Vancouver event, Python Night, Introduction to PySpark and AsyncIO. Hope I pronounced this properly. Asynchronous programming. And so our mission at Women Who Code is to empower diverse women to excel in technology careers. Our vision is a tech industry where diverse women and historically excluded people thrive at every level. Our values focus on the mission, always remember why we're here and who we're here for. Design for inclusion, make space, embody a culture of belonging, advocate for change, live leadership. Think like live leadership. No, live leadership, champion each other, and as a community, we are powerful. And lastly, journey forward. So recharge, celebrate wins, and break barriers. Yep, and we have, see if I do my math out, 360,000 members in 147 countries. And our code of conduct. So Women Who Code is an inclusive community dedicated to providing an empowered experience for everyone who participates in and supports our community, regardless of gender, gender identity and expression, sexual orientation, ability, physical appearance, body size, race, ethnicity, age, religion, socioeconomic status, case, creed, political affiliation, or preferred programming languages. Question or issues. I'm not sure if I can post the link. So it's womanwhocode.com/code of conduct or email contact@womanwhocode.com. And this is now a donation page. Your donation creates change. Every dollar donated directly supports programs that are changing the face of tech. Our work ensures that technologists in the industry today have access to skills, resources, and network needed to rise. It's womanwhocode.com/donate. Because I believe like Women Who Code states they do have the tax status as a nonprofit. So yeah, pretty cool. So let's get started for our event. Python Night, Introduction to PySpark and AsyncIO with Asynchronous Programming with Rhea Rodrigues. Hope I pronounced your name correctly. If not, please correct me, Rhea. Rhea Rodrigues. She is a lead at Women Who Code Vancouver and also a data scientist at Royal Bank of Canada. And our other speaker, Chethana Gopinath. She is a lead at Women Who Code Python, our technical track, and is also a software engineer at realtor.com. Speakers, and let me just pull up the bio page. So Rhea has over 2 years of experience designing, building, and deploying machine learning systems at scale. Wait, I created a slide so I wouldn't have to read the other page. There we go. Rhea has over 2 years of experience designing, building, and deploying machine learning systems at scale. She has a background in engineering and business and lives in Vancouver, Canada. Currently, she works as a data scientist on the cybersecurity team at RBC, which is Royal Bank of Canada, where she ships solutions to minimize the risk of insider threats and data exposure. And I'll read Chethana's file. So Chethana is a software engineer at realtor.com and lead at Women Who Code Python. In addition, she also serves as diversity chair at PyCascades Conference. She loves problem solving, sharing knowledge within her communities, and spends her free time experimenting with new cuisines and flavors in her kitchen and exploring beautiful scenic places. And okay, we can ignore that slide. So for the format of tonight's talk, our speakers will present on their topic. If you have any questions, feel free to post them in the chat. And after both Rhea and Chethana have completed their talks, then we will answer their questions. Sounds good? Okay, so Rhea, I am going to stop sharing so you can share your screen. And do you want me to describe your talk presentation?
I think I'll just go into it because it is an introduction. So I think I can just go into it. Yeah.
Okay, so I'll do stop share and hand the microphone over to you.
Do you see the first slide that says introduction to PySpark?
Yes.
Okay. Alrighty. So Hi everybody. I'm just going to be talking about a very introductory topic to PySpark, and I just for context, I put these slides together in November last year for a presentation I did within my organization for the interns actually. So if you've never heard of PySpark or anything, I think this is good talk to hear because it's like I said, it was my target audience was interns. So hopefully this is fun to listen to as well. Okay, so a little bit about me. Eliza got my name right. She pronounced it correctly. I'm Rhea Rodrigues. For anyone who's joining from Vancouver, I went to SFU. I did computing science. And then I did the RBC Amplify internship. And I was able to get a full-time offer from that. And so I joined as a data scientist full-time at RBC. I've been on a couple of different teams and worked on a bunch of different projects. And if there's one more thing I can tell you about myself, I'll tell you that I'm a huge Taylor Swift fan. But enough about me, let's go into PySpark. So yeah, these days, knowledge is more accessible than it's been at any other point of time in history. So even though we have knowledge, accessible, one of us can't know everything. Each of us has different levels of expertise. So whether you've heard of PySpark or Spark in passing and don't know what it really is, or if you've never heard of it before and wondering what the hell I'm talking about, that's okay. My aim for this little presentation I have is to help you from going to having little or no idea of PySpark to get you to think about it and see how useful it could be, and maybe even explore and go study it yourself. So, oops, I missed a slide over there. But I guess as an example, I want to talk about web usage logs. So most organizations these days keep a track of your browsing activity because you're usually on a VPN. So for example, this is one of the data sets that I work with. It looks a little bit like this. It's not exactly the same, but just as an example, on the 1st of November, 2023, when I want to check how many logs of like browsing activity were logged on that one day, it came up to 18 million. And when I measured the time it took for me to read in that data, it took 3 minutes. So you can imagine that as the size of, that data grows, it takes even longer time to read in the data. And usually we're not working with 1 day's worth of data. We're usually working with a week or even a month or multiple months worth of data. So that time to read in the data, just reading in, just adds up, and we need faster data processing technology in order to do things fast enough so we can add business value. Because if we spend too long processing some data, like time has already passed and we've moved on to the next thing in the business. And so any results we provide are not very helpful. So for example, let's imagine you work at a financial institution and you have a massive data set of transactions, and it takes way too long to process this data set of transactions on the machine that you're currently using. For example, if you have a fraud detection problem, you want to be able to detect any anomalies or fraudulent transactions in near real time so you can minimize damage to the clients. And because the current machine you're using takes too long to process the data, you might think, okay, I'm going to add a bigger machine to the problem. And maybe you want to add an even bigger and better machine to the problem. But spoiler alert, this kind of solution is not going to scale very well. So what else can we do to solve the scalability problem, right? This is when people started thinking about something called horizontal scaling, which is when you combine multiple machines to do a really huge data processing task. And this is also where the idea of parallel processing comes in. And there's a couple of things you want in a parallel processing system. You want some kind of efficient communication system so that all these different machines or processors are able to communicate with each other and kind of complete the task, work together and complete the task. Another thing you might want in a parallel processing system is some kind of monitoring capability. So you have an overview of what task is progressing to what degree on all the machines. Another thing you might want is something called task distribution, which is basically this idea that not all the, or rather, all the machines are processing equal amounts of data so that it's not just one machine or two machines that are doing most of the processing and the other two machines are idle. You don't want that to happen. And there's a lot of task distribution algorithms available. And another thing that's good to have in a parallel processing system is this concept of redundancy, which is basically this idea that helps us avoid a single point of failure. You want to be able to copy the data that is on one machine to a second or even a third machine, just in case one of those machines fails, you're not lost any of your data. So if only someone had, designed all of these features into some technology, it would have been great. And there is such a technology with all of these features, and that's what we're here to talk about tonight. And that's basically Spark, which embodies all of those things I talked about, right? So communication and task distribution, and really allows us to leverage parallel processing. So what's Spark? This is the textbook definition I picked up from the documentation. I'm just going to read it. It's Spark is a fast and general engine for large-scale data processing. Some of you might hear that and think, okay, I know what that means. And for some of you, you might be like, what is she talking about? And so what I really mean is that Spark allows us to work with big data like it was small data. So it gives users the illusion that we are working with regular data sets. You don't feel that too much time has passed between a certain amount of processing, because that's Spark's job, to make you feel like you're working on a regularly sized data set. The other thing that that definition talked about is that Spark is distributed. So like I said, it gives you the illusion that you're working on a single machine, even though behind the scenes it is several machines working together. But it is seamless, which is to say that when you're coding, you don't have to imagine you are coding for more than one machine. You can just use your regular function calls and just program the way you've learned to program on a single machine, and Spark takes care of the distributed processing behind the scenes. So this is a good image for what I mean when I say the illusion users have been using Spark versus what's actually happening in reality. And then finally, Spark lets you program in multiple languages. It has APIs for all of these languages. But today, we're going to be focusing on the Python API, which is conveniently known as PySpark. So you might want to take notes at this point or don't. I'm just joking. You can just listen to me. So when I showed you all a picture a couple of slides ago of like 4 machines communicating with each other, that's not exactly how Spark works. I lied a little bit. This is more like a more accurate representation of what's actually happening behind the scenes in Spark. It's set up so that there is one main machine which is assigning tasks to multiple worker machines. But even this is not the most accurate visualization of the Spark architecture. If I really wanted to be specific, I'd show you this, which is from the documentation. There is the driver program, the cluster manager, and several worker nodes. And maybe you can go read about this. We're not going to go into this level of depth tonight. So we're going to stick with the previous visual. Another thing we can talk about here is Spark's architecture. So one of the things the definition mentioned, if you remember, is Spark is a general engine. And when you say it's general, it's usually referring to this idea that you're able to do a lot of different things with Spark. And these are all the different things you can do with it. So there is support for SQL and data frames, which is basically the capability you would have with a traditional SQL database or even Excel, right? So anything you do with a SQL query or Excel, or data aggregation, for example, you can do with Spark. But the data is obviously much, much larger than you could fit into one computer. Another thing you could do with Spark is streaming. So when you think about, again, a financial institution constantly receiving transaction data, and to be able to process that in real time, Spark has this API called the streaming API, which enables us to process this kind of continually incoming data. Another thing you have is the machine learning library. It has a lot of very frequently used machine learning algorithms already built in. And then it also has support for graph algorithms, which is also a very cool thing for a lot of applications I know teams across my organization work on. And then again, these are like the different API Spark exposes for working with different languages. And for tonight, we're going to talk about Spark SQL and data frames and Python API specifically. So a little bit of history. So at the start, Spark had RDDs, which is a way of organizing data that has very little to no structure to it. So the schema of the data was very loosely defined, which also meant you got a lot of freedom while working with the data. But as you can imagine, there was also a lot of errors you run into and more time spent debugging because you had this loosely defined schema. So the next thing that was introduced after this is something called data frames. But before I talk about that, one more thing about RDDs is that when I took my first Spark course in university, our first assignment had us work with RDDs, and it was such bad code. Like the code looked ugly. And as you can imagine, a lot of time spent running into errors and debugging it. But it was all good because that was just the one assignment before we moved into data frames for the rest of the semester. But that one assignment really made us appreciate how much better data frames are. And data frames are, like I said over here, structured in that they have a schema that is well-defined. And there is another API that Spark has called data sets that is even more structured than data frames, but we're not going to talk about that tonight. So let's just talk about data frames over here. It looks like this. So if anyone has worked with pandas data frames before, you know what I'm talking about. This is a very similar concept to the pandas data frame. If you haven't worked with the pandas data frame before, you can think of this as a table, a tabular representation of data, even an Excel sheet, if you will, or a CSV file. So you have the columns and the rows, and every row represents one record in your table. The final thing I want to talk about Spark is Spark operations. And there's two types. You have transformations and actions. And when we talk about transformations, so think of a data frame, right? And you want to do some kind of data processing over here. You might want to select a couple of columns or sort the data in a particular column in like an ascending or descending order, for example, or maybe you want to filter on a certain condition, filter certain rows on a certain condition. So whenever you're doing this, you are changing the original representation of the data frame. You're changing or transforming the original data frame. So these are transformations. Another thing about transformations is that nothing really happens. Like there is no execution Spark is carrying out. And I'll explain that in a second. But the other kind of operation is an action. So when you're actually putting your data frame to work, when Spark is actually executing output, that's when it's called an action. So for example, write to the disk or a count of all the rows in your data frame, or a show so that it displays the rows. That's when you're actually putting the Spark engine to work on the data frame. So for example, if I say I want to select the name and the city columns from my data frame, that's a transformation. And if I say order by, so that's another transformation I'm adding. So these are two transformations. And let's say I want to execute this line. I run it, but nothing really happens. There is no execution that's happening on the Spark engine. The execution will only happen when I add an action. So when I say, for example, select name and city, order by the city in ascending order, and the show. So when I say n is equal to 10, I want Spark to show me only the first 10 rows. When I ask Spark to give me the first 10 rows, that's when it will actually first select the columns and then sort this city column in ascending order and then give it to me as output. So you need an action to actually have any execution happen. And this is why Spark is called lazy. It doesn't begin execution of the data frame until an action is called. You might have a series of logical transformations like we have over here, and Spark will not do anything. It will save all of those transformations until an action is called. So it will queue them all up. And this is actually a pretty useful feature because it allows Spark to combine all of these transformations and apply its own optimizations and make the execution plan that Spark has ultimately faster. Like the user doesn't have to worry about optimizations at this point. It's something Spark handles behind the scene. So that's something called lazy evaluation that Spark does. And that's all I have for you. I will mention resources and I'm only going to mention the documentation. There's a lot out there, but whenever I have a question, I find myself always going back to the documentation. And then if you wanted a place to begin with, just getting started with the SQL basics and the data frame API is a good place to start. You don't need to get into many other things. This is enough for you to build something useful. And then if things go wrong, and they might go wrong, there's a lot of people on the internet who are helpful, and there's a huge community around PySpark, and you'll be okay. And I guess the last thing I had was Q&A, but I'm not sure if we're going to do that now or at the end, but I'm going to pause right now.
Thanks so much, Rhea. I see a few questions chat for to answer, and we can just hand the microphone over to Chethana. But yeah, Rhea, thanks so much. Applause. Amazing presentation, really in-depth topic. I'm interested to see the next time you'll do a follow-up. This topic, see all the new updates or new things you learned to do with like PySpark from this talk. So yeah, so Chethana, we'll hand the microphone over to you.
Awesome. Let me just start sharing real quickly. Okay, can you all see my screen? Hopefully move this out of the way.
Yes.
Okay, perfect. Hey, everybody. Welcome and welcome to this part of the session. We're going to be talking about asynchronous programming and AsyncIO. The basic takeaways from this talk that I feel that we all should leave with are: what is asynchronous programming, a little bit about AsyncIO, and maybe some resources at the end where you feel confident enough to start doing a lot of asynchronous programming. So yeah, without further ado, let's get started. Okay, so we just spoke about asynchronous programming, but before that, what is synchronous programming? Let's jump right into this small snippet of code. If you see here, this is like just a general Python script. The execution would start from if name equals main, execute tasks, and then you'll go into this function that is execute tasks. You have a list of tasks. There's 3, and then in synchronous programming, how you would usually go by how you would usually like execute this is you'll take task by task, and then you'll finish one task and then move on to the next task and then move on to the next task until the task list is over. So a simple way to do that would be like a for loop and then calling the execute task function on this so that it does task by task. Okay, so that's fairly simple and easy to understand. But what is asynchronous programming in this specific context? So it's the same snippet, almost the same. There's like certain things that are added to it. We'll talk about that in a second. So the execution, again, it starts at if name equals main, which is the entry point of our program. And then we go into AsyncIO.run, which is how you run an AsyncIO application. a small one or a program. So it starts by saying AsyncIO.run execute tasks. So we move to this function that is execute tasks. And in this, I've added another thing to the tasks. The previous one just had a list of strings saying task 1, task 2, and task 3. Here I've added another number to it, making it a list of tuples. So task 1 has task 1, 2, task 2, 1, and the third one. Okay, yeah. So for this specific scenario, let's see how how AsyncIO would execute this. So in this case, don't think too much about like what coroutines are and all of that. We'll get into that in the next slide. But basically, you would take each task and you will pass it into this other function called execute task, execute a single task. And then you'll pass in the task and then the name, the string task 1, and then the number with it. And you'll pass it into your next function. And what it does, the next function, what it ideally would do is the second parameter, I didn't tell you what it was, but it's like a delay or like a time to sleep. Basically, if you call AsyncIO.sleep of delay, it's basically if you send 2, it's like sleep for 2 seconds, something like that. So the order is this: task 1, task 2, and task 3. This is what happened in synchronous programming, but in this, the order will change. And I just wanna see if folks are able to like get to like, what do you think would be the order in which the tasks are executed? There are like 3 tasks, and all 3 of them have to be executed. And so what do you think would be the execution hierarchy of the 3 tasks? If you do think about it, I'll just wait for a second. If you put it in the chat, that would be awesome. Else we'll talk about it. No worries. Okay, I'm gonna go ahead and oh, perfect. Task 1 would finish first, then task 1, and then task 3. That's a good try. Rika says 2, 1, 3. Nice. We're getting answers. 2, 1, 3, 2, 1, 3. Okay. Okay. Oh, perfect. Everybody's already on par with what we're going to be talking about. And all of you are right. So we'll start with task 2 first, because it has a sleep or delay of 1 second. And so that would be completed first. So task 2, task 1, and then task 3. So awesome. Great job, everybody. So why does this happen? That's what we'll get into in the next portions of this talk. But we do understand that because task 1 has to wait 2 seconds, task 2 finishes, and then we come back to task 1, and then we do task 3. It's kind of like a loop where, okay, fine, I'm going to wait for you to finish. I'm going to do the next one first, and then I'll come back to you. So it's something like that. Awesome. So let's move on to AsyncIO, because we spoke a bunch about AsyncIO over here, and we wrote a lot of code based on it. So let's talk about it. So the whole purpose of AsyncIO is to be able to achieve concurrency when you do tasks. And this was introduced, this was built in from Python 3.4 and above. And so what do we mean by that? We just saw it in the previous example. So while one task is waiting for input, so why would task 1, why would it be, we wrote that there was a delay of 2 seconds. Imagine it was another thing. It wasn't asleep or something like that. It was waiting for input. Task 1 is waiting for input from a user or something like that. And task 2 won't wait until task 1 finishes. Task 2 is going to begin next immediately while task 1 is waiting. There's no waiting for one to finish and then come to the next and so on and so forth. So basically, yeah, that is concurrency. And so how does AsyncIO do this? It has a single, the architecture is that it has just one single thread for execution and a single CPU core for processing. And so it's very paradoxical, right? Like, wow, you would think, yeah, so you would think that maybe, you know, like if it's going to be doing a lot of concurrent things at the same time, then maybe there's a bunch of threads. Each thread will pick up each task and perform that task. And you would expect a lot more, in terms of resources for it, but yeah, this is what we got. So with just a single thread, how do we make multiple tasks execute concurrently in AsyncIO? So what I'm going to show is just like two main core concepts that AsyncIO uses. You can probably read a bit more about it later, but I just want to introduce the topics to you so that we all kind of don't feel intimidated by asynchronous programming. So yeah, let's go. The first component when we think of AsyncIO are coroutines. And so you saw that before when we created we created a variable called coroutines, and it created a bunch of coroutines in between. And then we executed all of those tasks by doing gather. Let me go back to that real quickly. So we created a list of coroutines here, and then we called AsyncIO's gather, and then we executed those tasks. Cool. So that's what coroutines are. They are basically functions where you can think of them as, okay, the function will be started. You can enter, and then you can basically pause and then go to another one and then come back to that. And so they can be entered, exited, and resumed at many different points. So basically, they use async await syntax. If you notice, the function definitions, they were async and then the def keyword and then the function name. And when you saw the async, there would already be an await. So async await. That's the syntax that coroutines use. All right. And so I've just written down what generally happens in coroutines. But the thing is, these are all specific separate set of tasks that are happening, you know, maybe like they're happening concurrently. But what is it like, how is it that they're able to, what is making them move from one, what is causing the move from one task to another and stuff like that? So that's where event loops come in. So this is basically like the brain of AsyncIO. And so it handles the execution of coroutines. It handles any IO tasks that come with it, and also control change. You don't need to know completely about event loops because this is handled under the hood, but you should probably understand how this is at least happening in AsyncIO. So those are the two core concepts. There's definitely a lot more that you know, that asynchronous programming is like a huge thing, and there's definitely a lot more to understand as we go on. So when can we use AsyncIO? Definitely, as we saw here, because it doesn't have too many resources. It has a single CPU. And so doing really hardcore CPU heavy tasks is probably not your use case for it. But most of the time, like we can try using it when we're doing when we're maybe working on web applications and things like that. We can definitely like bring it into our have it in our arsenal, you know, bring it into our code and stuff like that. Okay, so just like a quick real world example, because so far we've just been talking about tasks and what happens if one task waits and the next one continues and all of that. Let's quickly like look at a real world example. So let's look at a synchronous situation, a synchronous case. So you have an application here, and then you have an external server, and your application makes request 1 to the server, and it waits. Your application waits until it can make the next request. It waits for the response. And only if the first response is received, you'll get it back, and then the next one, and then the next one. So this is probably going to be a lot of waiting cycles, and probably going to take a lot of time. And so we're going to look at an asynchronous example. The same thing, Flask application, and then a server, request 1 comes in. While request 1 is doing its thing on the side, we can send in the next request, and then probably if it gets back the response, you know, just do that. But if there's a lot more processing, then you go to the third request, and you notice that this is more like it doesn't wait. It doesn't keep waiting, and it doesn't spend a lot of time on it. It just keeps doing whatever it can in the time that it has. So that's pretty cool. It's quite optimistic as well. So that's nice. And the source for this is I've linked it here. I think I got it from an article online when I was like reading it. But yeah. Okay. And this is, sorry, I skipped real quickly, but this is a little bit about AsyncIO that I have for tonight. I don't want to overload with a lot of info, but I do want to make sure that we are at a point where we feel like, okay, this is something that I can start working on. The major thing about this is just like Rhea was also mentioning, there's a lot of things online. There's so much information online that it's definitely a lot. It's very overwhelming, but I would suggest the Python docs are the place to go for this as well. There's also a lot of really amazing conference talks. Maybe I'll link some of them in a little bit, but there are a lot of people who've spoken about this before. So just wanna mention that. And speaking of conference topics and talks, I just want to plug in PyCascades, because it's an incredible conference. It's a regional conference directly funded by the PSF. And if you really want to see or experience an incredibly diverse and inclusive conference with a lot of incredible tech content, definitely check it out. I've also linked like the previous year's talks there. There's a lot of talks even before, just to understand a lot about Python. It's mainly a Python conference. So I just wanted to bring that in. If you have any questions, definitely like email me, the organizers. And yeah, and also you could connect with me, LinkedIn, email. And that's all I had for today. Thanks so much.
Thank you so much, Chethana. That was an amazing presentation. It was easy to follow along. I feel like I have to like rewatch like both you and Rhea's video again, just to like let the content like sink in knowledge. So yeah. And yeah, just like PyCascades. I know I forgot to do this beginning of the thing, but like I'm Eliza. I'm director of Women Who Code Vancouver. Recently started head of engineering at Rodrigues Labs, and was formerly affiliated with the Women Who Code Python Leadership Fellow. Also chair PyCascades. I can vouch this awesome Python conference. I believe they post all the previous year's talk for free on YouTube, and they'll have the in-person event in Seattle. So yeah, excited about that. Oh yeah, and Ray has posted our updated social links on Linktree, linktr.ee/woman who code Vancouver. I've updated the volunteer links. I know the womanwhocode.com/Vancouver page has information there too. So yeah, and we're also looking for more chapter leads, and like we'll try to do like this year like more in person and virtual events. But yeah, it was an awesome events night. So let's start digging through questions we had. Where did I see the first question? Larry had a question about, I think, to the cloud. Rhea, it was during that slide where you have the computers and they were like lit up talking to each other. Do you want to answer that one?
What was the question?
The question, like, or maybe Larry can clarify in the. Oh, there's a question, more of a statement. Okay. Thank you, Larry. It's hard to reach out on the internet, right? So I'm so glad we have emojis. Another question it's from Penny. They're saying if my client needs their data to live in British Columbia, could PySpark be used?
Yeah, as long as you're actually storing the data. So PySpark is not going to be storing your data. You can use a different machine to do that. So as long as you're not storing your client's data on AWS server that's in South America or like outside BC, you should be okay. Yeah, to answer your question, yeah, if your physical disk is in BC, it shouldn't be a problem.
Great answer. Thank you, Rhea. And it looks like I'm pronouncing the name correctly. Deidre, question about data frames pandas, and Larry answered, and then Deidre, my phonetics, had a follow-up question. So to clarify their question, is the data frame used in PySpark constructed from the pandas library, Rhea?
No, it is separate from pandas. Pandas is a separate library from Spark. So no, it is different.
Great. It's good to hear. And then Chethana, your talk was so informative. There were like no questions. But I guess like question for you, like how did you feel like when you started like diving into like asynchronous programming? Was it just like something you found yourself like doing every day, or just like you saw it as like a topic and decided to, I don't know, I'm pulling at straws.
Yeah, good question. I basically was wondering, okay, like this is something that I've come across in a conference talk or something some time ago, and I was wondering, oh, let me actually like think more about this and talk more about this. So it's more like some stuff that we should be aware of, and that will definitely reduce like your runtime, and it's really good to experiment with. So I just thought let's talk about that today.
Sounds like a lot of fun. And oh, so we did a few questions. Laura's asking, for async programming, how do you deal with the race conditions? Because that's a common mistake that they see.
I think at least from what I understand, I think for handling race conditions, it would definitely depend on the style of how you call these functions, or like how you make these requests. Definitely feel like the handling should be done on your side, or like the person who makes these requests. And so yeah, I might need a little bit more context on like the specific race conditions, maybe like in which context at least. But yeah, it's definitely dependent on the person who makes it. But yeah. Next question is awesome. For the next question, for the async, is there a try-catch block to handle errors similar to JavaScript? I don't think I came across any try-catch blocks, but it would definitely be something that we could incorporate in probably. But Python, like Larry says, Python also has a try catch. We could definitely add error handling depending on where you're incorporating AsyncIO, I feel.
It's good to know. Thanks, Chethana. Rhea, I have another question for you. Since you work, I'm gonna put it under the umbrella like cybersecurity. Do you have any recommendations for us to stay safe with our banking internet?
I'm sorry, can you ask that question again?
Since you're like, I guess, kind of under the umbrella like cybersecurity, do you have any suggestions for us to, like, stay safe with our banking internet things?
I
Not
guess
for-
the most simple one is like your passwords, right? Have long passwords,
Mhm.
just as long as possible, because the longer it is, the harder it is for them to crack it. And by long, I mean like literally like have a sentence or a phrase, but make it more complicated than just letters. I think that's like something everyone should do.
Okay. It's good to hear. Thank you. Yeah. And oh, so there was a follow-up question for you with PySpark from Larry. Do you want to read it, Rhea?
Yeah, sure. How do you anomaly of fraud detection using Spark? It's not how do you perform anomaly detection with Spark? You can perform an anomaly detection with a lot of different technologies. There are a lot of anomaly detection algorithms out there. What Spark enables us to do is implement those algorithms and have it process really large data sets that would be impossible on like my MacBook from 2020, right? Because PySpark allows you to use the power of like multiple different CPUs. So it's not about, I think your question is a little like you're not asking the right question maybe. There's another comment here. Clustering and looking, oh, you mean like how am I doing anomaly detection? So yeah, there's a certain amount of clustering that's involved, so that's unsupervised, which has its own problems because we don't know if we are right or wrong. And then looking for outliers. So there's a lot of different unsupervised algorithms out there. I'm not going to like there's too much basically. Sometimes we also have label data, which we get from the business, which is helpful so that using that we can train a supervised learning algorithm, but that usually doesn't happen. But yeah, to answer your question, just I know I'm not trying to I guess how
You're not
do I
being vague, but it's hard to be specific, right?
Yeah, but these are very general techniques. It has nothing to do with like one company. A lot of people use it for a lot of different applications. So anomaly detection has not only applications in fraud detection, but like even in like the medical field, you want to be able to detect anomalies in like, for example, medical images. I see a thumbs up, so I hope I've answered your question.
That was great. You did a great job, Rhea. It's like 1 minute to 8. I can't believe we finished on time tonight. There's no other questions. We'll wrap up tonight's event. Thank you everyone for attending, whether you're local or not local from Vancouver. We will post more events, I think, in our meetup page from Unicode Vancouver. Also, you can look on unicode.com for other events happening or other Python related events. But yeah, it was great to see everyone here virtually get online. see thank yous in the chat for both the speakers.
Thank you, everyone.
Thanks, everybody.
Welcome. And then after this, we have to send the request to make this into a recording to post on YouTube. So the recording will be up soon. We'll send that to Global. Yeah, thanks everyone for joining tonight. I guess we'll see you online or at our next in-person event once we figure out a topic for that. But on the link tree, if your company's like interested hosting event or we talk idea, just submit it in the form and like we'll see that. If I don't see it, then the other two directors may see it like in the group email. But yeah, thank you, Rhea. If you like need that, like I think it's also on our Instagram and Twitter. If Linktree is like too long to remember. Okay, so happy day before Chinese New Year Eve. Happy February. See everyone next time. Okay, bye.
Good night.